Okay, so still on 1.1 in Trig, basic equations. Let's take a look here and see where we're at right now. We just finished up example 5, and looks like Wolverine is all stuck there. Let's see what happens here eventually. Okay, but we just finished up. This whole section is on basic equations, and now we're going to solve here. This is jumping the gun a little bit. We're going to solve, but solve now for variables. You went over this stuff in Algebra 2, so this shouldn't be anything too new or too basic. But anyway, when you're looking at something like this, we want to solve for f. Okay, so what most of you, your natural instinct is to FOIL first, move things over, and try to solve it. But the thing is, you don't always have to do that. When you're sitting here and you're staring at this in parentheses, it's like saying 5/9 times all of this. So let's get rid of that fraction. So what I'm going to do is I'm going to multiply by the reciprocal to get rid of the fraction on both sides. And the reason why I'm doing this step is they cancel out still. I have 9/5c on the other side, but now I have something nice and neat. This is much easier to solve for f. Much easier to solve for f than if I took that through and had a fraction and had to continue to multiply. So now to get f by itself, all I'm going to have to do is add 32 to both sides. The 32's cancel out, and there's your answer already done. So the hardest part of this problem, very simply, was that right there, is getting rid of the fraction right off the bat. So in example 7, now I know when you look at this one, this looks like it's more challenging than it actually is, but this one is really not that hard either. But here's the big problem that I see that students have with this problem. They tend to think that this root goes the whole way across and covers this 2, but it does not. This root and this 2 are two completely different things. Two completely different things. So keep that in mind. So, what I want to do is, whenever you have a root in a problem, any root, cube root, square root, fort root, doesn't matter what kind of root, whenever you got a root in a problem, try to get the root all alone on one side first. So, to get this root all by itself, I'm going to subtract this 2 to both sides. So, that gets rid of the 2. And this is what I have left. 5 minus 2 is 3 on this side, and I just have the square root left over on that side. Okay. Keep in mind this is a square root, so the opposite of a square root is to square something. Now that I have the root all by itself, let's get rid of the root. So to get rid of the root, since it's a square root, I'm going to physically square both sides to get rid of it. And what I showed everyone here in this step is that you can rewrite the square root as 4x minus 7 to the 1/2 power. They're the same thing. The square root and the half power are the exact same thing. And the reason why I did this is to help you realize why we're squaring it, because a half times 2 gives you 1. That's why the square root and a square cancel each other out, because a half and a 2 are reciprocals and they end up canceling each other out. So that's why the square root, you can square it and it gets rid of it on both sides. But whatever you do to one side, you got to do the other. So now those are gone. Leave me with just the 4x minus 7, and 3 squared is 9. This is a much simpler problem for you guys to solve now. All you need to do is add 7 to both sides to get rid of that 7. So I got 4x equals 16. Divide both sides by 4 because the 4's cancel out. And 16 divided by 4 is 4, so your final answer is x equals 4. Alright, these can get kind of crazy and kind of intense, but once again, you can't solve this problem until you get a root on one side all by itself. So the easiest way I know of to get one root all by itself, all alone on one side, is why don't I move this 2 root x over to the right. So these cancel out, leave me with root 3x plus 2 equals 2 root x. The reason why I did this is now I have this root here all by itself. This root isn't by itself, it has a 2 there, but this root is. So now that this root is all by itself, just like the last problem, right? What's the opposite of square rooting something? Squaring it. So all I did again was rewrite it. 3x plus 2 with a root is the same as saying 3x plus 2 to the half. And this is like saying x to the half. So to get rid of halves, I'm going to have to square both sides. But remember, I have to square everything on this side. Well, this is easy. A half and a 2, that cancels out. So all I have left on that side is a 3x plus 2. But what it's kind of hard to see over here is this 2 needs to go through to both items. So notice how this 2 goes through to that 2 to give you 2 squared. And a half and 2, they're going to end up canceling out, leaving you with just the x. So really, that's why you end up with a 4x on this side. Because this 2 has to go through. 2 squared is 4. And square and a half they cancel out, leaving just the x underneath. So 3x plus 2 equals 4x. So I'm going to minus a 3x on both sides, and I get x equals 2 as my final answer to the problem. Okay, so the tricky part here is getting this root by itself, not so tricky, but remembering when you square both sides, that 2 needs to go through to both items, that 2 out in front and the root. Example 9, I already have a root by itself, so I'm going to square both sides, right? Because remember, 2x I can rewrite as 2x to the half. So I'm going to square both sides, but notice how this whole side gets squared, right? It's x minus 4 squared, because the whole side gets squared and the 2x is left over. X minus 4, big boo-boo, people want to just square both items. That's wrong. You can't do that. This x minus 4 squared means I actually have x minus 4 times x minus 4, and the 2x is still over on this side. So x times x is x squared. X times negative 4, negative 4x. Negative 4 times x, negative 4x. Negative 4 times negative 4 is positive 16, and that equals 2x. Combine my like terms. Negative 4 and a negative 4 is negative 8x. So x squared minus 8x plus 16 equals 2x. Now, because this is a quadratic equation, I'm going to try to get everything onto one side. Okay? So normally, you try to combine all your like terms. I'm going to move this 2x over because I realize it's a quadratic equation. And now I'm left with x squared minus 10x plus 16 equals 0. A quadratic equation, which I can try to factor. Can you think of two numbers that multiply together to give you a negative 16, positive 16 that add to give you a negative 10? Negative 2 and negative 8 work, right? So x minus 2 and x minus 8 are my factors. So x minus 2 and x minus 8 are my factors. So basically the opposites are the answers. What makes this 0? A 2 would make it 0. So x equals 2. And what makes this 0? 8, right? Because 8 minus 8 is 0 as well. So we see what makes those 0. I take a good look here. Separate them. As I said, just do the opposite. So if you didn't show all this work, remember, it's the opposite. That's the answer. Opposite of negative 2 is 2. Opposite of negative 8 is 8. So those are the answers. But you have to check your solutions. So let's plug in the 2. When I plug in the 2, 2 times 2 is 4. So I got a negative 2 and root 4. It's not true because the square root of 4 equals both plus 2. The square root of 4 equals a positive 2 as well, not just a negative 2, so 2 doesn't work. 2 times 8, square root of 16 is 4. 8 works, so 8 is the only correct answer for the problem. So this is why you have to check your answers sometimes. 2 doesn't work, but 8 does. Okay, so you got to keep that in mind when you're doing these problems. Some answers don't work, and some answers do work when you're doing these. And when we come back here, I will try to finish up. I'm pretty sure we'll be able to finish up the rest of section 1.1 in Trig on basic equations when we come back.